Hi Math 2 Enhanced. This is a video about pages 4, 6, 4, 7, and 8, sorry. We'll select problems from those pages. So let's take a look. Let's start with problem number 1. On this problem, if I want to build the polynomial function, I have to figure out what factors would give me the answers x equals -1. So I know that I would have had to have an x plus 1 factor. What would give me the answer x equals 5? I would need to have an x minus 5. And finally, what answer would give me an x equals -2? Well, that would have been an x plus 2. And when I set each of those equal to 0, I would have got the 3 answers that are above. So now I just have to multiply. You could multiply any 2 of them together. Multiplication is commutative. I'm going to pick these first 2. And so box or FOIL, whatever's your preference, and you get x squared minus 4x minus 5 times x plus 2. And now I have to multiply those together. I like to do trinomials and binomials in a box method. I just find it's very organized for me, but you can also do this with elaborate distributive property. Just be careful you don't lose anything. So x squared times x to the first is x cubed. When we're multiplying like bases, we add the exponents. When we're dividing like bases, as in factoring, we subtract the exponents. So x times -4x is what? -4x squared. Then I get a -5x, 2x squared on the bottom, what? -8x and -10. So now I look on my diagonal and I gather up my like terms and then I write my answer. So the polynomial that would have had these 3 as its answer, its solutions, its roots, would have been x cubed minus 2x squared minus 13x minus 10. So let's take a look at number 2. So number 2, the x equals 3 is easy. I know that that would have been x minus 3 as a factor. The 2 plus or minus 2 square root of 2 is not as easy. I can't, so aside on the side of my page, I'm going to rewrite my x equals 2 plus or minus 2 square root of 2. So now this type of answer with the plus minus would result when I complete the square or use quadratic formula on a trinomial, 3 terms, that doesn't factor. So the only way I can get this answer is if I completed the square or use quadratic formula. So I need to then use something to get back to that trinomial. So if you watch the previous video, the video notes, I showed the steps to do reverse complete the square, and I explained them in that video. So right now I'm just going to do those steps. So step 1 was to move the constant. So I'm going to subtract 2 from both sides and get x minus 2 equals plus or minus 2 rad 2. So now that I've isolated the plus or minus term, I'm going to, step 2, square both sides. So when I square this side, I'm going to draw right through the plus minus, because when I square it, the plus minus goes away. When you're solving with the completing the square, for instance, the plus minus doesn't happen until you take the square root. So now when I do the reverse and square it, the plus minus goes away. On the left side, I have x minus 2 times x minus 2. On the right side, I'm going to square each one of these. This is 2 times the square root of x. So I'm going to square each part of my product. So 2 squared is 2 times 2, or 4. And the square root of 2 squared is the square root of 4. Square root of 2 times the square root of 2 would give me the square root of 4. And I know that's equal to 2. That happens every time. Basically what's happening is the 2 from squaring it is canceling your square root symbol. They're inverse operations. And so I'm getting x squared minus 4x plus 4 equals 8. My last step, my third step, is to set it equal to 0. So I'm going to subtract 8 from both sides and get x squared minus 4x minus 4 equals 0. So this was the trinomial, the quadratic factor, that gave me this 2 plus or minus 2 rad 2 as my answer. So I'm going to write it in, and I'm kind of close together. Sorry about that. It happens when I'm writing on my iPad. I get x squared minus 4x minus 4. And so now you've got to multiply like we did before. Just to save time in this video, I'm not going to do the multiplication this time. If you feel like you've made a mistake in the multiplication, the solutions are in our folder. Go ahead and take a look at it. But if you multiply correctly, you should get x cubed minus 7x squared plus 8x plus 12. So let's take a look at 3. 3 also has a reverse complete the square. So first of all, the x equals 8 is easy. So my p of x is equal to x minus 8. But my 1 plus or minus 3i squared of 5 is not as easy. So let me write it off to the side. And x equals, 1 plus or minus 3i square root of 5. So the first thing I'm going to do is move my constant. So I'm going to subtract 1 over and get x minus 1 equals plus or minus 3i square root of 5. I'm now going to square both sides. So over here I have x minus 1 times x minus 1. And on this side, the plus minus went away when I squared it, so it's gone. So I just have 3i square root of 5 squared. So it's a product. I'm multiplying all of them. So I'm just going to multiply each one. I'm just going to square each one, and then I'm going to multiply them. So 3 squared is 9. I squared is negative 1. We memorized that in the last unit. If I have I squared, it's equal to negative 1. And the square root of negative 1 then would just be I. So then now I have the square root of 5 squared, which when I multiply them, I'd get square root of 25, which is 5. So now on the right side, on the left side, I have x squared minus 2x plus 1 equals negative 45. My last step is I'm going to add 45 over and get x squared minus 2x plus 46 equals 0. So this is the trinomial that gave me x equals 1 plus or minus 3i square root of 5 for my answer. So I'm going to plug that in. This is my other factor. It's x squared minus 2x plus 46. And now I'm just going to box or FOIL. Again, if you're having trouble with that part, all of my work, the solutions are in the folder. Come see me if you want help with that. Your final answer for p of x for this one should be x cubed minus 10x squared plus 62x minus 368. So now number 4, this multiplicity of 2 tells me negative 2 is a root twice. So really I could think of this looking like this. Negative 2 is an answer twice. So when I go to write p of x, x equals 5 would give me an x minus 5. X equals negative 2 would give me an x plus 2. And x equals another negative 2 would give me another x plus 2. This is very much like number 1. I just have to multiply all 3 of these and get my answer. Again, all the solutions are in the folder. You can check your answer there. So let's go on down and look at the last 2. So in this particular problem, I have another multiplicity of 2. So that means that x equals 2 is a root twice. So when I go to write my polynomial, I don't just write x minus 2 as a factor once, but I write x minus 2 as a factor twice because I had a multiplicity of 2. Same thing, x equals 5 gives me the factor x minus 5, and I've got to write it twice because there's a multiplicity of 2. This is for binomials. I will end up with an x to the 4th. There is a lot of multiplying going on here. How do you do it? There is 2 different ways, but they're the same thing, same answer. The way I like to do this is I like to multiply 2 of them and get a trinomial, and multiply 2 of them and get another trinomial. And then yes, I multiply the trinomials. I notice some students multiply 2 of them, then multiply in the third, now they have 4 terms, and then multiply the last binomial, meaning they have a 4 by 2 box. That's fine. We wind up with the same answer in the end. So personal preference. So here when I multiply the first 2, I get x squared minus 4x plus 4. Again, if you need to use the FOIL method or box method off to the side, you just have to pause this video, take a minute, and do that problem off to the side. This would give me an x squared minus 10x plus 25. And then this is what I'm now going to box. So I'm going to create a 3 by 3 box. And I can put either one on either side. So I'm going to go the x squared minus 4x and the plus 4 here, and the x squared minus 10x and the plus 25 here. And then just like a spreadsheet, I'm going to multiply row and column. So x squared times x squared is 2 plus 2. So that would give me an x to the fourth. Negative 10x to the first times x squared would give me a negative 10x. 2 plus 1 is 3 to the third. And then I would get a 25x squared. So let's take a look at the next row. I would get negative 4x cubed plus 40x squared minus 100x. Okay, and our final one would give me a 4x squared minus 40x and plus 100. So I look along my diagonals. Now be careful, your like terms don't have to be on the diagonal. It's just that generally they are. So it looks like when I write my final answer for p of x, I get x to the fourth, what is this? Negative 14x cubed. And if I add along here, that's 65 and 4, so plus 69x squared. What is this? Minus 140x, and then finally plus 100. Yikes, fun, huh? So number 6 has fractions and a single x equals 0. So let's take a look at this one. So first of all, let's talk about the x equals 0. This tells me that x minus 0 or x plus 0 is a factor, which is just x. So traditionally, if x equals 0 is a root, we just write a single x in front of all the other factors. Done. That's what I do when x equals 0 is one of my roots. So what about x equals positive 1/2? Well, that would be x minus 1/2. Same for x minus 3/4, and same for x plus 3. So now let's deal with the fractions. We don't like to do our problem with fractions. So I'm going to write this as basically what happens is my denominator pops up in front, and I'm going to get 2x minus 1. Same thing here. I'm going to get 4x minus 3, and I still have my x plus 1. Or I'm sorry, my x plus 3 at the end. Let's talk about what's going on with those fractions. This is really x minus 1/2, let's say equal to 0. So I can clear the denominator. If you remember that from grade school, you would clear the denominator by multiplying both sides by the least common denominator. In this case, my least common denominator is 2. So that's 2 from looking at it right here. So I'm going to multiply everything by 2. 2x, when I multiply 2 times negative 1/2, I get negative 1. When I multiply 2 times 0, I get 0. So x minus 1/2 and 2x minus 1 are equivalent. That's why this works. And the nice thing about it is now I don't have any fractions to multiply. This is a long multiplication problem. You can do it in any order. Personally, I prefer to leave the single x for last. I noticed some kids in class immediately multiplied that in and got 2x squared minus x. That's fine. But make sure you only multiply it in one binomial, not all three. Multiplication doesn't work that way. I typically will multiply 2 together, and then I will take that answer and multiply with the x plus 3. And then finally, I'm going to have this big, long answer, and then I will distribute my x in last. Again, all of my work is in the folder. If the multiplication at this point is what's bothering you, please come see me in office hours and I'll help you out with that. But you can see all the steps if you look at the solutions in our Unit B folder. So next, for the students that came here looking for help on page 6 and 7, let's get started on page 6. So the first problem, I must take out my GCF of x squared, or the problem's not even doable. So when my greatest common factor includes the variable, if you don't factor it out, you can't do the problem. If my greatest common factor is an integer, like 3 or 2 or 4, technically you can still do the problem without factoring it out. You're just going to have to factor it out later. For example, I'll talk about that in a different problem. But in this problem, I have to take out an x squared. While I'm at it, I'm going to take out a 3x squared, simply because that's my greatest common factor. So when I divide 3x to the fourth by this, the 3's cancel, and x to the fourth divided by x squared would be x squared. When I divide negative 3x by x cubed divided by 3x squared, I would get a negative x because my 3's cancel. My x cubed and my x squared cancels to x to the first. 3 minus 2 is 1. And my negative 60 divided by 3 gives me negative 20, and my x squareds completely cancel. So now I need to factor x squared minus x minus 20, if it's factorable. So let's see. I'm going to put my a times c, a which is 1, at the top, so that's negative 20. I'm going to need two numbers that multiply to that for the sides. And I'm going to put negative 1 at the bottom because that's the coefficient of x, that's my b. So remember, it's a times c at the top and b at the bottom. And now I think of my two numbers, and that would be negative 5 and 4. So because my a is 1, I can just write the negative 5 and 4 in my parentheses. And I get 3x squared times x minus 5 times x plus 4. This is completely factored. So if my problem asked me to completely factor it, I would write this answer on the answer line. It doesn't. It asks me to solve it. It's equal to 0. So I'm going to set 3x squared equal to 0. I'm going to set x minus 5 equal to 0 and x plus 4 equal to 0. So here I'm going to divide both sides by 3. I'm going to get x squared equals 0. I'm going to just take the square root of both sides to get x equal to 0. I'm going to come back to that in a moment. That's one of my roots, a real root. X equals 5 is another root. Subtract 4, x equals negative 4 is another one. You might be saying, well, that's weird. This is a fourth degree polynomial, but I'm only getting 3 answers. Technically, and I'm going to talk more about this when we go over the answers in class. Technically, because this was an x squared, this x equals 0 actually has a multiplicity of 2. You're going to understand multiplicity a little better, well, probably a lot better, when we get to graphing. So for right now, I want you to realize, because it wasn't a 3x to the first, because it was a 3x squared, that 0 has a multiplicity of 2. If that had been a 3x cubed, yes, my x equals 0 would have a multiplicity of 3. So there's 2 of my real zeros. X equals 5 is another one. X equals negative 4 is my fourth one. Those are my 4 roots, and they are all real roots because they're really numbers I can graph on the x-axis. So number 2, I'm not going to spend a lot of time on. Well, actually, I forgot. It has an imaginary, or no, it just has a square root answer. Well, let's go ahead and do it. We're on a roll. So x squared, it would be my GCF of my first 2 terms. So this is just a grouping problem. I get x plus 2 minus 6. I get another x plus 2 equals 0. So this gives me x squared minus 6 and x plus 2 for my fully factored. You can't do anything else with the x squared minus 6. 6 isn't a perfect square. You're done. That is fully factored. So let's set my x squared minus 6 equal to 0, my x plus 2 equal to 0. I get x equals negative 2 when I subtract 2 from both sides. And over here I get x squared equals 6. I take the square root of both sides. I get x equals plus or minus the square root of 6. This is my 3 real roots. The square root of 6 is simply a decimal. I don't know what it is without a calculator. I would need to do square root of 6. But it's just a decimal answer. I can physically put a dot on the x-axis at positive square root of 6 and negative square root of 6. So these are 3 real roots. No non-real roots there. On number 2, you have to subtract the 9 over before you can get started. You get 2x cubed plus x squared minus 18x minus 9 equals 0. I believe I want you to take a minute, pause this video, factor this by grouping on your own, but stop when you have it fully factored. Don't solve yet. I want you to take it down to when you have it fully factored and come back to this video. So I hope you have it down to at least x squared minus 9 times 2x plus 1 equals 0. So now I'm going to try to make this really clear in class on Thursday and Friday, but you can stop now and set x squared minus 9 equal to 0 and 2x plus 1 equal to 0 and solve and get your answers. but it is not fully factored. So it depends on what your question asks you. If your question's asking for it to be fully factored, you do need to take a moment and write this as x plus 3 and x minus 3 because this is the difference of two squares. This is fully factored. However, when I solve it, whether I use the x squared minus 9 equal to 0 or whether I use x plus 3 and x minus 3, you're going to get an x equal negative 3, an x equal positive 3, or if you solve the x squared minus 9 equals 0, you're probably going to get a plus minus 3. It's the same thing, a positive 3 and negative 3. And then here, 2x plus 1 equal to 0, you would get 2x equals negative 1. You get x equals negative 1/2. These are my three real roots. And even if you solved this guy and you're looking at x equals plus or minus 3, that's still two real roots right there. So to total, you have three real roots for this cubic third degree equation. Quadratic style is technically something we're going to learn on Friday, so I'm not sure when you're watching this video, but if you're watching this video before we learn this method, go ahead and fast forward at this time, but I'm going to do it at this time just to keep it consistent. So this is a problem that I'm going to factor the same way I factor trinomials in the last unit. I'm going to put my a times c at the top. So 1 times negative 28 is negative 28. I'm going to put my b at the bottom. That's negative 3. And now I'm going to think of my two side numbers. So negative 28 and negative 3 is making me think of negative 7 and positive 4. Now, because my a is 1, I can just put the negative 7 and negative 4 into my parentheses. I don't have to change it to factor by grouping. Now be careful of your parentheses. This is not an x squared and an x. This is an x to the fourth and an x squared. So my leading term should be an x squared in both my parentheses, and then I can put my side numbers in simply because there is no, simply because my a is 1. So now I have to solve both these. I'm done factoring. There isn't anything else you can do. So I'm going to set x squared minus 7 equal to 0 and x squared plus 4 equal to 0. And I get x squared equals positive 7. So I get x equals plus or minus the square root of 7. This is two real roots. That's a decimal I can graph on the x-axis. Here I'm going to subtract 4 over. I get x squared equals negative 4. Take the square root of both sides. I get x equals plus or minus 2i. That's a negative 4, so 2i. This is two non-real roots, and that is my 4 roots of this 4th degree polynomial. So let's take a quick look at number 5. On number 5, before I get started, I have to add the 14x over. Remember to get it equal to 0 before you start factoring. And when I write it, I'm going to write it in between my two terms because I'm going to write them in order of their exponents. So for me, this seems much more organized and usable when I put the x cubed in the middle because it's in the middle of x to the 5th and x. So this particular problem is, it has a GCF. My GCF for this problem is x. You could say 2x or x, but you have to say the x. So I get x to the 4th minus 7x squared plus 10 equals 0. So now this is another quadratic style problem. I would set up my diamond, 10 at the top, negative 7 at the bottom. You get 5 and 2. They're both going to be negative. And since my a is 1, this is one where I can throw those side numbers into the parentheses. If my a was 2, 3, anything else, I would have to do factor by grouping. So I have 2x times x squared minus 5 and x squared minus 2. And then I would begin solving those. Why don't you pause this video and solve each one of those and come back for your answer. So here are my answers. How did you do? The one thing I want to talk about here is this 2x in front. Since it had a variable, it's part of my solutions. Anytime I have an x out there, if it had just been a 2, it doesn't have anything to do with my x-intercepts. But since I had a variable there, it's part of my answers. This gives me one real root. This gives me 2 real roots because plus or minus square root of 5 is just a decimal. This gives me 2 more real roots for a total of 5 roots, and they're all real roots for this 5th degree problem. So let's take a look at number 6. On number 6, I need to get everything on the same side. So when I do that, I have to add 10x over, I have to subtract 30 from both sides. This problem is a pretty straightforward factor by grouping problem. Check my work and answers in the locker or in the folder. And if you have any questions, please don't hesitate to come see me or ask in class. Number 7, let's take a quick look at him. Number 7 is another problem where you do this of a GCF of 2. The thing is, since it's just 2 and not 2x or not an x, technically you don't have to take it out to get the right answer. So again, you can get the correct answer and leave your 2 in there, or you could factor out the 2 and then do your math. Again, this one's pretty straightforward factor by grouping, either way you do it, setting your factors equal to 0. So please come check your answers, check your work in the folder. If you need help, come see me in office hours or ask in class. So let's take a look at this last problem. This problem is not doable unless you take an x cubed GCF out. So this has a GCF, and unlike number 7, I can't do anything with it unless I take the GCF out because the GCF includes my variable. And I have to take out the x cubed. I can't take out an x, can't take an x squared. I have to take out that greatest common factor. While I'm at it, I'm also going to take out the -5 just to make my numbers easier to work with. But I have to take out the x cubed. So here we go. So my first term when I do that would be a positive x squared. X to the 5th divided by x cubed. 5 minus 3 is going to give me a 2. That's where I'm getting my x squared. I'm going to get a -10 x to the 1st, x to the 4th, divided by x cubed is going to give me an x to the 1st. And then finally I'm going to have a positive, 24. When I divide -120 by -5, my x cubes cancel, and this is equal to 0. So this is a pretty easy factoring problem. You could use your diamond method if you want. Because my a is 1, I'm just going to throw my side numbers, -6 and -4, into my parentheses. So now this problem, I have to set all my parts. Oh, this is a 3. I'm so sorry, right there. If you could please look, I had wrote on the top line -5x cubed, and the next line I had wrote -5x squared. I'm sorry. So I'm going to set everything equal to 0. So I'm going to set -5x cubed equal to 0. I'm going to set x minus 6 equal to 0 and x minus 4 equal to 0. This gives me an x equals 4. That's one real root. This gives me an x equals 6. That's my second one. Now I'm actually going to get 3 real roots in this next problem. I'm going to divide both sides by -5, and I get x cubed equals 0. Now I'm going to take the cubed root of both sides because the cubed root is going to cancel my exponent of 3. And when I do that, I get just x, and the cubed root of 0 is 0. But this root actually has a multiplicity of 3 because I had an x cubed equals 0. So that's where I'm getting my 5 real roots because 3 of them are right here at x equals 0. Again, you'll understand more about multiplicity when we do graphing in lesson 4. So this concludes page 7, and I'm going to make page 8 a separate video. So thank you very much, and I look forward to seeing you in class. Bye.